Today, we're going to be doing lesson 12.1, and this is actually 12.4 and 12.5 in your textbook if you want to go back to the textbook and follow along. We're going to be looking at solving by square rooting and factoring. Now, solving by factoring we did in unit 1, so that is a little bit of a review, but I do have a few examples to bring back how to do that. We're going to be focusing on solving quadratics. So the first thing I want to do is kind of go over what is a quadratic. So a quadratic is a polynomial where the highest exponent is 2. I'm going to zoom out a little bit. Now we're going to see two main forms of quadratics. We have this first one where we have it in the format y equals a times x minus h squared plus k. This is going to be a format that we like to use when we're graphing. We're also going to learn how to solve in this form. We also have the standard form. So this is standard form. And just for right now, this one was called vertex form. So for standard form, we have y equals ax squared plus bx plus c. So what the differences are is for the standard form, we took the x minus h piece, we did our foiling, multiplied it out, multiplied the a, combined like terms, and now we just have a trinomial. So those are the differences. The key ways to notice the difference is we have the power of 2 on the outside of the parentheses. Versus for the standard form, the exponent, we have an x squared term and a bx term. So this is how you can tell the difference between standard form and vertex form. Now, let's start with how do we solve by square rooting. I'm going to give a couple seconds to let you finish copying this down. Okay, so for this first one, we're going to solve this by square rooting. Now, notice in the directions it says to find all real solutions. In 12.4, we're going to be looking at complex numbers. So we're going to look at something you might have heard of imaginary numbers. And in that case, we're going to find all solutions. And that has to deal with when we're taking the square root of a negative. Today, we're just not. We're going to deal with just the real solution. So today, no square root of a negative number. Okay, so that's what that means. So let's look at example 1. When we're solving in this format, I want you to notice that we don't have that bx term. We don't have that middle term. So we can go straight to just undoing our equation. When we undo these, I want us to think of undoing PEMDAS. So undoing parentheses, exponent. Let me write it down. Multiplication, division, addition, subtraction. So we're going to undo that. So we're going to go backwards. So the first thing we're going to do is get rid of our addition, subtraction. So I'm going to add the 36 over. So I have m squared equals 36. Do I have anything to undo for the multiplication or division? No, there's just a 1 there. Now I undo my exponent. How do I undo the squared? I take the square root. Something we need to remember is whenever we take the square root, it is plus or minus. And I'm going to go into why in a second. So I get m equals plus or minus square root of 36 is 6, and that is our answer. So why plus or minus? Well, when I'm looking at m squared equals 36, 6 squared equals 36, and if I do negative 6 squared, that also equals 36. So we have our two answers there. And this is kind of a way you can check to make sure that your answer is correct. I'm going to go ahead and give you a second to try example 2. Okay, so for example 2, and if you needed more time, please feel free to pause to allow the students more time. I'm going to undo my addition or subtraction. Now here I do have a number in front of the x squared, so I'm going to undo my multiplication division. That's the next step, undo that. And now I'm going to undo my exponent by taking the square root. Remembering whenever I take the square root, we're plus or minus. Now here I notice that I'm taking the square root of a negative, so this is going to be no real solution. Go ahead and try example 3. So for example 3, we notice that we don't have just 0 on this side. We notice that, again, there is no bx term. There's no middle term. So when there's no middle term, we can go just straight to our undoing of PIMDAS, solving by square rooting. So we're going to undo our addition subtraction. We get 4d squared equals 0. Divide by our 4. We're undoing our multiplication division. Undoing our exponent, not forgetting that plus or minus. I get d equals 0. Now, 0 is neither positive nor negative, so we just have it as 0. Let's go to example 4. We notice here that we are more in that vertex form. So when we're in that vertex form, we're still going to be undoing PIMDAS. So undo our addition subtraction, add the 12. Undo our multiplication division. Undo our exponent. Not forgetting, whenever we take the square root, we are plus or minus. Now here's where that P comes in. We're undoing what was in the parentheses. I'm going to kind of just go backwards again. How do I undo what was in the parentheses? I add, what did I forget? I forgot to carry down my plus or minus. So we're going to add the 2. Now here we get x equals positive 2 plus or minus 2. But we can do this math. 2 plus 2 is 4. 2 minus 2 is 0. Go ahead and try example 5. For example 5, we notice we have nothing to undo for addition subtraction. We do have this 2 to divide for multiplication division. We're going to undo our exponent, not forgetting our plus or minus. I now have plus or minus square root 3 equals x plus 3. I subtract 3 over. And my final answer is x equals -3 plus or minus root 3. If I ask for the answer to be left in radical form, simplest radical form, I would leave it like this. If I ask for something to the nearest tenths or hundredths, you would plug -3 plus root 3 and -3 minus root 3 into your calculator to get an answer. That is solving by square rooting. What I don't want you to do on these is we are not going to multiply them out. Okay, so don't do this. Don't multiply them out like that. Just go ahead and go through your undoing of PIMDAS. All right, so now we're going to review our solving by factoring. We're going to factor. First thing we need to note, one side has to equal 0. Does this side equal 0? Yes. Note that this is in standard form. So this is going to be one of our methods for solving in standard form. Let's look at our quadratic, g squared plus 4g minus 32. Can we factor this? Well, we're going to make our 2 sets of parentheses. To get g squared, it's going to be g times g. -32, we have 1 times 32, 2 times 16, 4 times 8. A lot of you might have already gotten it. It's 4 and 8. So now we have to play with our signs. So let's check. These inside give us 4g. Outside give us 8g. So this means I want a positive 4, so I'm going to have a plus 8 and a minus 4. So I give me a minus and a plus. That does in fact give me positive 4g. So I'm going to make those a little darker. Okay. I'm actually going to erase them. All right, so now what we can do is take each of our binomials and set them both equal to 0 by the zero product property. So I have g minus 4 equals 0, which means g equals 4. G plus 8 equals 0, which means g equals -8. So my final answer, g equals 4 and -8. Okay, so now let's go ahead and go over to example 2. Let's note, does one side equal 0? Are we in our standard form yet? Not quite. So let's move that 10 over. We now equal 0, so we can go to our factoring. We want to get 3h squared. I'm picturing 4 slots. I want to get 3h squared. So one of these is going to be 3h. One of these is going to be h. Now, in order to get 10 with the last two, I'm either going to be 1 and 10 or 2 and 5. So let's try 1 and 10. I got 30h and h. Now I note that they're both going to be positive because these are both positive. Does this make 17? Nope. So let's go ahead and switch the 10 and the 1. That's going to give me 10h, 3h, that's 13h, not 17. Let's try the 2 and the 5. I'm sure you guys have already got there before me. 2h, 15h. That does give us our 17h. So I'm going to go ahead and darken those and erase. Thought I have room. Okay, so now I take you to my binomials. I split them by the zero product property. 3h plus 2 equals 0. H plus 5 equals 0. Here I get h equals negative 5. Now I'm going to subtract 2. Then I divide by 3, and I get h equals negative 2 over 3. Final answer, h equals negative 5 and negative 2 over, oh, I wrote negative 2 over 3. And that is solving by factoring. So, key thing to remember the difference. If we're in standard form, if we have this bx term or bg term, then right now we're going to be solving by factoring. If we don't, so notice no bg term, not in standard form, then we're going to solve by square rooting. And that is 12.1.